Hello everyone, we're going to go over section 8.1, basics of percent. So percents are the result of expressing numbers as a part of 100. The word percent means per 100, per 100. How to express a fraction as a percent? So first we're going to turn the fraction into a decimal. And then we're going to move, you either multiply by 100 or move the decimal point over 2 places to the right. And you need to add the percent sign. So that is exactly what we are going to do. We can use a graphing calculator, or you can use the scientific calculator. But the step one is the same. So if we can get a very view of the calculator. So if I use the graphing calculator, it's going to be 5 divided by 8. Okay? And then to turn that into, in this calculator, to turn that, that's how we turn it into a decimal. So 5/8 is equal to the decimal 0.625. And then we can move the decimal point over twice. And that will give you the final answer. That is 62.5, and insert the percent sign. Okay, so but if you want to multiply that answer by 100, that's how you can also get the answer of 62.5. okay, so the best method is the one that you remember what you're being assessed. So the next one, 3 3/5. So there are different ways to do this one. You can keep the 3 the same, the whole number, that's a mixed fraction. So you can go ahead and convert the fraction part into a decimal. So it will be 3 divided by 5, and that gives you 0.6. So 3 3/5 is the same thing as 3.6. And then you just move the decimal point over twice, and that will give you 360, and then you insert or add the percent sign. That's it. So that becomes 3.6, and then move it over twice, 360%. The next question, it says, express the decimal as a percent. We have done so many of this, we can do this while we sleep. So we're going to move the decimal point over twice, and that will be 47%. That's it. The next one, decimal to percent. You're like, no problem. This is going to be 1, 2. That will be 129. Insert the percent sign. So the next one, and the last two for this page, express each percent as a decimal. So when you see the percent, you're going to remove the percent sign, identify the implied decimal point. So if it says 19%, the decimal point is at the end. So you're going to move the decimal point over to the left. So as a decimal, 19% becomes 0.19, 0.19, or 1900th, which is the proper way to say that. So 180%. 180%, it has a decimal at the end. I drop the percent sign in order to turn this into a decimal. Move the decimal point over to the left, and you can answer 1.80, or you can also answer just 1.8. They are both correct, unless it states that they only want 1 decimal point or 2 decimal places. So make sure that you pay attention to the instructions on how they want the format of your final answer. So now we go to percent sales, tax, and discounts. So many applications involving percent are based on the following formula. Note that of implies multiplication. So use this formula to determine the sales tax collected by states, counties, cities on sales items to customers. So the sales tax is going to be the tax rate multiplied by the item's cost. And we all have experience with taxes, paying taxes. So suppose that the local sales tax rate is 7.5%, and you purchase a bicycle for $894. How much tax is paid? So you're going to, so they're asking for what is the sales tax. So the sales tax is going to be the tax rate But again, we should turn this tax rate into a decimal. So we're going to move the decimal point left twice. So 7.5% becomes 0.075. So the tax rate as a decimal multiplied by the price of the bicycle, that is $894. Okay, so we're going to enter this in our super helpful calculator. 0.075 times 894, and this is equal to $67.05. So your sales tax is $67.05. Don't forget the dollar sign. That's the sales tax, because it's not $67.05 of potatoes, it's $67. So the units are important, is what I'm trying to say before confusing myself more. So what is the bicycle total cost? So the total cost is going to be the price, the price of the bicycle plus the tax. And they're both expressed with dollar signs. So this is going to be the $894 plus the $67.05 that you pay in tax. So that's what we have here. I already have the tax there, so I don't just have to add 894. So you're paying, you need to make sure that you have $961.05. $961.05. That will be your total cost. Okay. So the next question, example 8. Suppose that the local sales tax rate is 8.25% and you purchase a watch for $49. So again, the first thing that I recommend that you do, 8.25%, turn that into a decimal. So this is equal to 0.0825. And here the price is $49. So the tax that you pay is going to be the tax rate multiplied by the $49 for the watch. So clear the screen so Dora is ready for input. 0.0825 multiplied by 49. That means that you're going to pay $4.04. So when you're working with money, if they don't tell you how much to round it to, make sure that you at least will be 2 decimal places. That is the implied rounding when you're working with money. Next, what is the watch total cost? So the total cost is going to be the $49 plus the tax, that is $4.04. So this is going to be $53.04 for your total cost. Okay, so that is your final answer on this one. So next, percent and sales price. So business reduce prices or discount to attract customers and to reduce inventory. The discount rate is a percent of the original price. The discount amount is the discount rate times the original price. So a computer with an original price of $1,460 is on sale at 15% off. So it's asking for what is the discount amount, or in other words, how much are you saving? So you're going to take the price of the item and multiply it by the percent. I recommend you express that as a decimal. That will be 0.15 in this case. So this is going to be the discount amount. Okay, so this is how much money you will be saving in this purchase. So 1,460 multiplied by 0.15, that amounts to $219. So if you take advantage of this sale, you're going to save $219. Now, what is the computer's sale price? So the price that you're going to pay is going to be the original price minus the discount price, minus how much you're saving. So that will be what is called the sale price. So you have to take that $1,460 and you subtract the discount of $219, and that gives you the price that you're paying is $1,241 for this computer. So this is the sale price. Okay, Next, a bicycle with an original price of $380 is on sale at 35% off. So what is the discount amount? So the discount amount, okay, is going to be the price, that is $380, multiplied by the discount that we turn into a decimal, 0.35. So we're going to take that 380 and multiply by 0.35. So in this purchase, you're saving $133. That is how much is a discount. So now, what is the sale price? So the sale price is going to be the $380 minus the $133. So you go to Dora and it says, Dora, please help me with this. And Dora says, no problem, my pleasure, just like Chick-fil-A. So this is going to be $247. That's how much you're going to pay for this bicycle. Okay, so we go to the last page. Percent increase or decrease. So they both have very similar formulas. They're both based on dividing by the original amount. And the numerator is going to be the difference of what is the increase and what is the decrease. So let's do it. So in example 11, in the year 2000, world population was approximately $6 billion. The data are from United Nations Family Planning Program and are based on optimistic or pessimistic expectations for successful control of human population growth. So projections in world population. So we're going to use this line for projection if it is a high projection. The middle one is for the medium projection, and the last one is for the low projection. So find the percent increase in world population from the year 2000 to the year 2150 using the high projection data. So the high projection data is this line right here. So let me make it more colorful for you. So this is going to be the pink line. So they're looking for what is the percent increase. So the percent increase is going to be what it was in the year 2000. In the year 2000, it was about, I say $6 billion. So this is 6 in billions of dollars. Then minus in the year 2150, it will be 30 billions. So that will be 60 minus 30 divided by the original of 6. But if you do this, you're going to get a negative answer, right? So what we're going to do is say, okay, so we're going to find the difference and make sure the difference that you get is positive. So I reverse the order. So the difference is the largest minus the smallest. And then this will give you 24 divided by 6. So you get a 3. And it says, what is the percent increase? So the 3, it has the decimal point at the end. So I have to move the decimal point over twice to get the final answer that this is an increase of 300%. So the answer that you get needs to be converted to a percent. So that's what we need to remember, because we feel that, I'm sorry, I apologize, 24 divided by 6 is not 3, it's 4. So this is going to be 400%. I apologize, I did it too fast. So this is going to be an increase of 400%. Part B, find the percent decrease in world population from the year 2000 to the year 2150 using the low projection data. So we're going to write the largest minus the smallest divided by the original. So in the year 2000, we know that it was 6 billion. In the year 2150, using the low projection. So if it is using the low projection, we're going to color that one in yellow. So the low projection is this line. So that's, you're going to use the particular line that they mentioned to determine the percent of increase or decrease. And again, in this case is decrease. So in the year 2000 was 6 billion. In the year 2150 seems to be 4. So this is going to be 6 minus 4. This is going to be 2 divided by 6. So this should give you 0.33. So you move the decimal point over twice, and this is going to be then 33% down. Okay, so the other one was an increase of 400,000. This one was a decrease of 33% in the population using the low projection. And that's it for this section. I hope it helps you do well.